Alright everyone, so welcome back to my channel. Today I'm gonna do a binary tree problem called binary tree zigzag level order traversal. So regularly when we do level by level order traversal, we go on this, and go this, and we'll like this. So in here you can see there is a result. We have 3, and then we have 29 and 15, 7. That is the next level. So we're gonna do a regular BFS function, and that is how we use to do level by level order traversal, right? So for zigzag, it's just a tiny bit difference. Let's say you have another number, just arbitrarily I have a 3 here, right? You go 3, you add 3, then you go from 20 right here, right? From left to right. So start with 3, you're going from left to right, right? From left to right. And then from starting the second level, you go from right to left. So it's gonna be 29, right? And then the opposite right here. So we go from left to right. So it's gonna be 3, 15, and 7. This look a little tiny bit complicated. However, we can solve this really easily. It's just how we change we just only need a flag. I could call this flag left to right, something like this, right? And then if this flag is true, I will have an array right here in every single level, right? If it's left to right is true, I will add the node. Let's say, let's start with the second level, 20 and 9, right? So left to right is, left to right is false, right? If left to right is false, I'm just gonna add on the right side of the array. So I will just append 20 right here, and then again, oh, actually, even if we go on this side, we will have to append to the left, right? So let's say we have 9 first, right? You add 9 here, you will have 9 right here. Since left to right is 4, you just need to add 20 on the left. And then it doesn't matter if you go on this side. Anyway, you just change the way you add to the result, and this is where you add to the result. Then you will have to decide again, right? 3, 15, 17. But since this one now is true, we will have a different array, right? We will just append like regular, like 3, 15, 7. We don't add, we don't append left. We just change the array that we append to the result. Now we append our values to the result. We don't make change when you add the values to the queue. So that's being said, let's try to code that up, and it should be really quick. So first of all, I have if not root. If there's nothing, I will just return an empty array. That is a base case, and then I'll have a queue. I have a queue dot append root. I have our flag left to right equal to true. We have our result right here. It's just a simple while loop with queue, and then we have our level. It's gonna be a deque for in ring of length queue right here. If we have left to right, oh, I have to pop the node. So node would be equal to queue pop left. So we have our level right here, dot append node dot value. So we have our value. If in the other way, right, we have to append left, right? And oh, maybe I should just say else right here. Yep. And then just a regular node left, node dot left, queue dot append, node left. And then I have node dot right, queue dot append, oh, append, node dot right, something like that. And then in here, when we finish with our loop, we just simply change left to right. So left to right equal to not left to right. This one is just switch from false to true, right? So add that to our result. So append list of our level, and then at the end we just need to return our result. And let me see, it works just fine. So the time and space complexity for this problem probably is gonna be O of n, both for both of them, because we have to traverse to every single node, and we need to have the queue to put every single node in there, and the level also same, put every single node in there. So hope you like our videos, and see you soon on the next video.